and thank you for joining us at Coalesce. My name is Elise Papineau. I'm a senior analytics engineer at DBT Labs, and I'll be the host for this session. The title of this session is Data as Engineering, and we'll be joined by Raazia Ali, who is a senior software engineer at GetUpside. Before we get started, I wanted everyone to take a moment to join us in Slack, please. You can join us in the Coalesce data as engineering channel of the DVT community Slack. If you're not a part of the chat, you have to join right now. Please visit community.getdbt.com and search for the Coalesce data as engineering channel when you enter the space. Once you're in the chat, please feel free to make comments, react to the session, post any questions you have for the speaker or other attendees as the session proceeds. After the session, the speaker will hang out in the Slack channel to answer your questions, but we encourage you to interact in the channel throughout the presentation. Let's get started. Over to you, Raazia.
Thank you so much, Elise. Hi, my name is Raazia, and I'm a data engineer at GetUpside. And today I am going to be talking about how a small but mighty team of 4 engineers supported GetUpside to be contributing 2 billion in local commerce using engineering best practices. We like to call it data as engineering. So this is our story about things that worked for us, lessons that we learned along the way, and the concrete results that we produced as an outcome. We will walk through exactly how our data team of 4 has gone from being the data experts to enabling all team members through data to make better business decisions. But first, let's start with who we are. GetUpside is bringing online personalization and attribution tools to the offline world to make brick and mortar commerce more efficient. Our users experience us as a free mobile app that helps them earn cash back on their everyday items. So, how is this making commerce more efficient? So, we partner with over 30,000 local businesses to provide offers to users in their area. We ingest billions of records representing millions of users and billions of dollars of commerce and personalize user experience through cashback offers. We deliver hundreds of millions of dollars as cashback to users and as incremental profit to merchants. And on top of that, we also give 1% of our revenue to sustainability efforts. So obviously, data plays a crucial role at every junction of our business. So with over 2 billion of gross merchandise value, GMV, running through our platform every year, we are working on a massive problem set and growing exponentially. Of course, the company's data needs are growing much faster than our data team could ever grow. So by mid 2020, we had 160 team members and only 2 data engineers. And by the end of 2020, we had 210 team members and only 4 data engineers. And on top of that, our data team was not able to keep up with the abundance of inbound requests despite their best effort. Requests would come in from external customers and internal teams. We would have to prioritize all those requests against each other. Our to do list kept growing, our response time stayed the same, and we were getting in the way of our own growth. So obviously, that wasn't working and something had to change. So we put our heads together and decided to change our mindset. So we went looking for problem solving inspiration, which we found within GetUpside as an advice from our co founder and VP of Engineering, Rick, to avoid the service mentality, as well as across industry. So we were very inspired by a talk by Emily and Taylor in last year's GPT Coalesce about how to run your data team as a product team. We did some creative thinking and broke the problem down to the basics. At the heart of every DBT model is a SQL query. Data consumers have excellent SQL skills. So, if we could somehow reduce the toolchain overhead of learning, developing, and productionalizing, we can potentially enable data consumers to build their own data pipelines using dbt. But the question was, how do we achieve that? The solution we found comes down to the 3 points of this self reinforcing cycle. Find willing partners across the company who were on board with the idea of self service if that meant getting their data needs satisfied faster. Acquire excellence in data ops to reduce toolchain overhead, and provide multidimensional learning and support resources to be able to scale faster by having patterns and answers available for the most common questions. In other words, analysts are excellent data chefs. All we are doing here is showing them how to use appliances. Once learned, they can cook all they want to their heart's desire or data needs. Internally, we are constantly learning from our experiences and improving our processes. Let's start with the first point of this cycle, building partnerships. This is the enablement model we use to engage with the teams. It allows us to work in partnership to get them what they need and to teach them how to self serve in the future. The exploration of an engagement can be team initiated, where they may have any current data related blockers, or if there is a new project starting off. Or it can be data engineering initiated, where we explore if we can help a team uplevel their analytic capabilities using the enablement model. Next is to establish and communicate the mechanics of quarter long partnership with the expectation of training a data X contributor. On the data engineering side, two team members are identified as primary and secondary leads for implementation, training, and coverage. The engagement is kicked off by data engineering team building data pipelines for the team. During this phase, we understand their data needs while educating them to understand their own data needs. We also establish a weekly rhythm of business that includes a sprint commit by the data engineering team, followed by a weekly stakeholder review meeting. Next, we enter the training phase, where we train contributors from the team to build their own models using hands on training, consultation, and code development. This also includes reinterpreting the weekly rhythm of business. Now, both the data engineering as well as enablement team commit towards a weekly sprint goal. Weekly stakeholder review meetings are repurposed as core development sessions as needed. In the self serve phase, the data contributors from the team are mostly trained and are able to self service through documentation, training videos, and example PR. Data engineering team transitions to a support role via office hours, design consultation, and Slack channels. An engagement is officially wrapped up once the team has either enough data modeling skills built to be self sufficient or the team's data needs have been satisfied for now. The next step is to achieve excellence in data ops to reduce toolchain overhead. This is crucial to reduce entry barrier for the non-engineers to get started with the DBT modeling. All four of us in the initial data engineering team are software engineers by training who moved into the data space. So our approaches are rooted into the engineering best practices. So this is where the data as engineering comes in. At the heart of our tool set is dbt and Snowflake, around which our whole data ops ecosystem is built. Our primary mechanism to load raw data into Snowflake is Fivetran. We use PagerDuty for alerts about data load issues in Fivetran and for dbt build cloud issues. We have a weekly on call rotation program in PagerDuty to have one team member on point to solve data and build issues and to shield the rest of the team from disruptions. All our data modeling is done in dbt. For anything and everything that dbt does not control, we use Terraform to define our infrastructure as code, like Snowflake administration, roles, and permissions. And of course, for reproducibility, we Dockerize our Terraform and dbt interactions. Having a robust data ops setup enables us to set up reliable and fully separated prod, dev, and CI/CD environments. We like to call them cycles of DB. So analytics is our prod database. It is structured according to the dbt recommended project setup. That is, starting from the raw database, each model has three checkpoints: sources, staging, and marts. We have purpose-built marts per application or usage, but our analytics.analytics mart is our general purpose analysis layer. All other purpose-built marts and data products, including Looker, source from this analytics.analytics mart. On the opposite end of this cycle are the dbt user databases. These are developers and researchers' playground. They have access to almost all of the prod data in their dedicated databases to experiment, modify, and research with a peace of mind for them and us that their experimentation cannot impact the prod data in any way while doing actual real work on real data. Their experimentation can stay localized forever, or if something needs to make it back into the prod, they can do a GitHub PR. Our PR pipeline is integrated with dbt Cloud to test those changes. Every push on PR triggers a dbt Cloud build in a dedicated CI/CD database with schemas per PR. The data team owns the PR approval, merge, and release process. The last element of the cycle is the clone database. Every time the main release build is triggered in the dbt Cloud, as a last step, it clones the prod database. The user database clones off of dbt clone instead of directly from the dbt analytics. This provides an additional layer of padding between prod and user environments. Notice that the sandboxes are on the opposite side of the prod database. Anything going in or coming out of either does not touch each other, achieving complete separation of environments. Here is a visual representation of how the analytics.analytics schema goes through the whole cycle of DBs in Snowflake, starting from the prod analytics database to be copied over to the analytics clone at release time. Then it gets pulled into a user's local sandbox. From there, the PR process takes it to the dbt Cloud database and eventually back into the analytics prod. All our builds are run in the dbt Cloud. We have four types of builds. Our CI/CD and release builds are part of our cycle of DBs, integrated by GitHub Actions. Besides that, we have scheduled data refresh and data test builds to ensure freshness and correctness of our analytics data. One last piece of our data ops setup is our roles and permissions structure. All data team members by default are Snowflake account and sysadmins. All non-team members have standard read-only access to our analytics mart. The basic analyst access can be upgraded with custom team or schema access to specific marts. Besides that, we have application roles granting required access to any specific application. When we decided to switch to the enablement model, we were faced with an interesting problem. Our standard non-member roles were too restrictive by being read-only, while our data engineering role was too permissive with admin privileges. In order to open up the dbt data modeling to non-team members, They needed to be able to read, write, all the way from raw to the analytics layer. That's where we developed the contributor role. In order to settle on the right level of access, we decided to dog food our own permissions. We moved admin roles to attached roles where they have to be explicitly assumed to operate, and switched to contributor roles by default. We kept on adding privileges to the contributor role as we kept on hitting the roadblocks till we reached the right mix of permissions. So the contributor role is a power user now who has read access to the raw, sources, and staging schemas, as well as full privileges to operate on their own DBT user databases. Last but not the least, the pillar that has enabled us to grow our enablement model non-linearly is the provision of the self-service resources. One of the things that we recognize and acknowledge internally and to our contributors is that we are enabling citizen data engineers on hardcore engineering toolchain without providing the resources for the contributors to refer back to in their own time and pace. Excellence in data ops and partnership with teams alone will not be as fruitful. Therefore, we strive to create a culture of support around our enablement model by training, documentation, and life support. Our documentation is structured around very simple questions a reader would ask themselves. Are they trying to get data into or out of Snowflake or work with data within Snowflake? Overall, as a team, we have adopted the handbook first methodology, originally inspired by GitLab's handbook first approach. We have committed as a team to continuously contribute to the handbook and to answer questions through documentation. For example, if a question comes to us through any of our support channels or enablements, we strive to respond by pointing to a link in our documentation. If the answer does not exist, we add it first to the documentation and then point to it. Secondly, we have taken to presenting via our handbook. We do not create slide decks. Instead, we update or augment to our documentation pages and present from there. Besides documentation, we provide training resources to our contributors. One of the most useful resources is DBT's very own Learn the Fundamentals of Analytic Engineering with DBT course to get new contributors started with the DBT development. Since we were all working remotely in the pandemic and communicating over Google Meet, we started recording our support and pairing sessions. The idea is that if one of the contributors has this question, others would as well. Our most popular tutorial is a video walkthrough of setting up your dev environment in DataGrip, which was recorded on a Vim while onboarding a new team member. To increase the data engineering literacy, we leverage the existing knowledge sharing platforms as seminar series, where team members take turns to present an ordered sequence of topics, building on top of the previous one. These sessions are recorded and shared in our handbook to be used later as self service resources by all. Our efforts were rewarded when one of the more recent contributors self trained themselves when pointed to our Getting Started with the DBT development page, and they said our documentation was very straightforward. It took us at least 6 months of continuously improving that page to get to a point where it is now intuitive to a new user. We now sometimes see fully fleshed out data modeling PRs by new contributors who have not gone through our enablement process. And just by using our self service resources, we're able to self train and produce quality data pipelines. Besides documentation and training, we have live support available through our Slack channels. Besides seeking help directly from the data team, the users have analysts and developer community channels available where their data or their data modeling questions can be answered by fellow users. The data team also holds weekly office hours where all team members are present to answer any questions by the contributors. This unstructured time can be used for code development, troubleshooting, debugging, general support, or even ideation. And of course, the data team members are always willing to jump on a call to help troubleshoot or answer any questions. So, all these efforts and processes, how has that impacted the overall process? Our efforts have enabled us to truly transition into an enablement team. Data literacy and data pipeline development have become common skills across GetUpside. Not only that the contributors Not only have the contributors from the citizen data engineers increased manifolds, but also multidimensional data insights have become accessible to everyone through Looker. Internally, our processes have improved manifold. The turnaround time for new data products has been shortened from delivering a product in multiple sprints to delivering multiple products per sprint. The data team is not at a risk of being a blocker for any data process anymore. In just 3 quarters, our enablement model has had a profound impact on the business as well as business processes, unlocking massive business growth, customer retention, and on top of that, satisfied internal and external stakeholders. Here is the mighty team of 4 that has accomplished all this in only 3 quarters, while setting up solid foundation for future growth and scalability. So if you know any data or analytic engineers, please send them our way. We are hiring at GetUpside. So what's next for data engineering? So we are now looking at solving next generation of data and user scaling challenges while maintaining data integrity and security. More recently, we have had some awesome data engineers join our team who are constantly looking at ways to eliminate bottlenecks in our global DBT tag to further optimize our analytics model for speed and scale. Having mastered data modeling skills, many of our contributors are now aspiring to build and own their data ingestion pipelines. This is an active area of research for us as to how we can safely upgrade the contributor role to enable ingestion into the raw database while maintaining oversight as well as ensuring data quality of the future models that will be built on top. We are now extending our first methodology over to our highly underutilized resource of DBT docs. We believe that data documentation should live as close to the data source as possible. Therefore, we are encouraging teams all across GetUpside to contribute their knowledge and experience about common data models and their usage directly to the DBT docs for everyone's benefit. Thank you so much for listening. I look forward to continuing the conversation in the chat. Thank you.